Hi, my name is Dr. Kamba. Thank you for joining us. This is Series 1, Unit 4 of our econometric tutorial. In this unit, I will be discussing the order of integration of variables and choice of model. In economic research or studies, especially studies that use time series secondary data or panel data, knowing the order of integration of variables by the researcher is very important because it is one of the criteria for making a choice of appropriate model of analysis for the study. For example, if we consider a study with 4 variables, y-dependent variable and x1, x2, and x3 independent variables. If all the variables are integrated of the same order, there are economic models that are designed to specifically handle such cases. Similarly, suppose the variables are integrated of different orders, we still have by theory models that can best handle such scenario. But if a researcher is unaware of this and he makes a choice of any model for his analysis without any regard to the order of integration of the variables of the study, then he may run into difficulties in interpreting this result. In fact, such misapplication or wrong application of model may lead to biased results, and this will affect his conclusion about the study. So now, what do we mean by order of integration of variables? Suppose we have a time series variable yt that is not stationary. The number of times the variable must be difference to become stationary is called its order of integration. Okay, now what are we saying here? All right. Suppose you have GDP and you subject it to stationarity test using ADF, PP, or any of the stationarity test options, and the data is found to be non-stationary. Then, to make it stationary, the data is differenced. And after the first difference, the data becomes stationary. Then we say that that data is integrated of order 1. That is, a data that is originally non-stationary but becomes stationary on first differencing, then the data is said to be integrated of order 1. That is, the order of integration of that variable for that data is 1. If the data is not stationary on first differencing but becomes stationary at second difference, then the order of integration of that variable is 2. We say that the data is integrated of order 2. So in general, if a variable is not stationary, but the variable has to be differenced 10 times to become stationary, we say that the order of integration of that variable is 10. That is, the variable is integrated of order 10. So, if a variable is integrated of order 1, it is written as I1, like this, I1. I1 means that the variable yt in this regard is not stationary originally, but after it is differenced once, it becomes stationary. If it is not stationary at first difference, but becomes stationary at second difference, then we say that the data is integrated of order 2 and it is written I2. All right. Now, a time series variable that is I1 is said to contain linear trend, while a time series variable that is I2 is said to contain quadratic trend. What we are saying here is that if a time series data is not stationary, but at levels but becomes stationary on first difference. It means that the trend that is responsible for the data not being stationary is a linear trend. On first differencing, the linear trend must have been removed. But if a data is not stationary at level, it is also not stationary at first difference but becomes stationary at second difference. It means that the trend that is responsible for the data not being stationary is a quadratic trend. Remember, quadratic models have the highest power of 2, linear models have the highest power of 1. So it means that for a variable that is stationary at second difference, the trend that must be removed is a quadratic trend. That is, it has to be differenced twice to achieve stationarity. However, a time series that does not contain trends, cycles, or drift does not require to be differenced. That is, here, once you test for stationarity and you find the data to be stationary, then we say that that data does not contain trend, it does not contain cycle, it does not contain drift, and we say that it is stationary at level. So we say that data is I-O. It is written I-O. I-O means that the data is stationary at levels. Therefore, it does not require to be differenced to achieve stationarity. All right, we said, how do we use the order of integration? What are the guidelines for using order of integration to determine the appropriate model for a study? Okay, in this table, I have 5 variables: inflation, interest rate, exchange rate, asset price, and real sector output. Then I conducted 2 categories of tests: the ADF at levels, the ADF at first difference. Then I also conduct PP, that is Philip Perron at levels, Philip Perron at first difference, and this is remark. This is my order of integration of the variables. So now we already know how unit root test is conducted. So these are the results here. Let's take inflation, for example. You can see that at level for ADF, the value is minus 2.92. Okay, then the critical value for ADF is minus 2.95. So this means that this value for inflation is less than this critical value, suggesting that ADF is not stationary. When the calculated value is less than the critical value, we accept the null hypothesis that the variable is not stationary. Then for PP also, you see this is the calculated value for PP, for inflation, using PP at levels, and this is the critical value for PP at 5%, minus 2.96. So we are considering the absolute values. So 2.90 is also less than 2.96, suggesting that at level, inflation is not stationary both for ADF and for Philip Perron. This bracket 1 you are seeing here, this is the meaning. It means it indicates that the maximum lag length I use in this test is 1. That is what it implies here. That is the 1 in the bracket attached to this 2.92 attached all through. Then this asterisk you are seeing here is telling us that, where is it? Yes, it indicates that this thing is, the estimate is significant at 5%. Anyway, we are going to explain that. So, in the nutshell, we are saying that inflation here is not stationary at levels. We decide to conduct the test again, but at first difference. And here we have 5.52 for ADF first difference, 10.2 for PP first difference. So if you compare 5.52 with 2.95, we see that the value of inflation at first difference is higher than the critical value, suggesting that at first difference for ADF, the variable inflation is stationary. That's why I put these two asterisks, suggesting that it is significant at 5%. Coming to PP is the same thing. You see that 10.2 is greater than 2.96, suggesting that inflation is not stationary at levels for both ADF test and PP test, but becomes stationary on forced differencing for both ADF and PP test. Hence, our remark is that inflation is integrated of order 1. So we do so for other variables. Interest rate is also not stationary at level, but stationary at forced difference for the two unit root tests we have used. If you look at exchange rate, ASP, that is asset price, and real sector output, they are all not stationary at levels, but they become stationary on forced differencing. Therefore, we say that all the variables used here are integrated of order 1. So in this case, we say that the variables are all integrated of the same order, and the order of integration is 1. That is, they are all stationary at forced difference. So when you have a variable of your study being integrated of order 1, all of them, then theoretically the appropriate model of analysis is given below. These are the conditions. When all variables are I1, the appropriate model of analysis is var if there is no co-integration, or VECM if there is co-integration. That is, the moment you have determined the order of integration of the variables of your study to be I1, to know which model is appropriate, we first of all test for co-integration. If you test for co-integration, perhaps using Johansen co-integration procedure, we're going to look at it in our next video, and the variables are found to be co-integrating. Remember, the first condition is the variables are I1. So the second condition now, we want to know whether these I1 variables are co-integrated or they are not co-integrated. If the variables are co-integrated and they are all I1, the appropriate model of analysis is VAR, that is vector autoregressive model. This is what econometric theory says. However, if we carry out co-integration test and we discover that all the variables are not co-integrated, despite that they are all I1, all the variables are I think I'm mixing it up. I was to say that if all the variables are I1 and we carry out the test of co-integration and we find that they are all co-integrated, the appropriate model of analysis is vector error correction model. That is, if they are co-integrated and they are I1. But if they are all I1, but we test for co-integration, we find that they are not co-integrated, then the appropriate model of analysis is vector autoregressive model. Thank you. We're going to continue in our next video. Don't forget to like, share, and subscribe. Thank you once again.